Okay, so this is get through it all today, so we're just going to get a start on this. And today we're just starting the chapter 1-6, and we're going to be talking about the measures of spread. So the simplest measure of spread of distribution is its range. Okay, the difference between the max and the min values. That's how you find the range. With the activity, and I'm not sure exactly, oh yes, the one that we are looking at, yes, actually it's in your section 1-6, you can read about it later. But there was a max of 80 and a min of 70. So this is, if you look at it later, you'll see that the range is 10. Okay? Okay, so the variance and standard deviation of a population. Greek letters are used for the mean, standard deviation, and variance. The mean is labeled M, and that's pronounced mu. Not moo, but mu. Okay? The standard deviation is sigma. This is a little sigma squared. You guys learned this earlier as the capital sigma, right? For your summation notation. But this is a lowercase sigma. It's got a little, it's like a baby with one hair sticking up, right? Okay? And the variance is just a sigma just by itself. The variance for a population is calculated from the squares of deviations or the differences of each data value from the mean, or mu. So what we're saying is each data point, call it xi, subtract the mean from it. That's your deviation, okay? So if you're looking at the square deviation, that's the variance. So this equals a deviation, and xi minus mu squared is a variance. Okay? Okay, we'll go over, I'll give you some specific examples in just a minute, okay? All right, the population variance is the mean of the squared deviations. So just write down these definitions for now. We'll go through them more, but what it is taking all these variances for each data point, adding them all up and dividing by the number of data points. Okay? Oh, the mean. Okay? In other words, it is the sum of squared deviations divided by the number of objects. N. The population standard deviation is the square root of what we just found, which is the square root of the population variance. And right now you guys are probably thinking I'm just saying wah, 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 wah. I'm guessing. Right? A lot of that? Okay. So if you look on the left column, it's a bunch of heights. So the x sub 1 is 70, x sub 2 is 71, x sub 3 is 71. Do you see what I'm saying? Okay. So the deviation is taking each one and subtracting the mean. So the first thing we got to do is find the mean. Okay? So we're going to add all that first column and divide it by how many? By 10. So we're going to take summation x sub I and then divide it by 10. Okay? 775? So the summation is 750 divided by 10, right? Equals 75. So that's the mean, right? Okay, so that's the mu in this case. All right, so now that we have the mu, ladies and gentlemen, we're going to find the deviation of each one. So you're going to take 70 minus 75 for that first one. What is the answer there? -5. Okay? 71 minus 75. -4. Okay? And once again, it's -4. 73 minus 75. -2. 74 minus 75. -1. Then we got 0. 3. 5. Good. Okay. Now the deviation squared. Okay, the deviation squared is 25, 16, 16, 4, 1, 0, 9, 16, 16, and 25. Sigma squared for this, after we've added up the sums, we're going to take 128 divided by 10. Okay, and that would be 12.8. Okay, so that's the standard deviation. The variance.
Wait, if the deviation had a number, would you add like the deviation total plus the other deviation squared total?
No, you're not going to add them together. No. You had to find them separately just so that you could find the squared one. Okay. All right, so now just sigma is 128, the square root of 128. It's a symbol, it's just sigma.
It's a lowercase sigma.
Yeah, it's the baby with one hair. Okay? That is 3.6.